Ever wonder what happens when a star reaches the end of its life? What magnificent spectacle takes place in the vast universe? Our universe, in its infinite expanse, is a cosmic stage where celestial bodies perform a ballet of existence. Stars, the prima donnas of this ballet, have a life cycle that is as fascinating as it is mysterious. Born from clouds of gas and dust, they shine brightly for millions, even billions of years. But what happens when the curtain falls? When the spotlight dims and a star dances its final performance? The answer, my friends, is nothing short of spectacular. As we delve into the mysteries of the cosmos, we'll touch on the dramatic finale of a star's life, a supernova. This grand explosion is a phenomenon that not only marks the end of a star, but also gives birth to elements that make up our very existence. Stay tuned as we explore the explosive finale of stars, supernovas, and their homes, galaxies. To understand supernovas, we first dive into the life of a star. The fascinating tale of a star begins with a humble cloud of gas and dust in the vast expanse of the cosmos. Within this cloud, gravity pulls the gas and dust together, and a protostar is born. This is the embryonic stage of a star's life, where it begins to grow by accumulating more and more matter from its surroundings. As the protostar matures, its core becomes increasingly dense and hot. At a certain point, the heat and pressure are so intense that hydrogen atoms in the core start to fuse together, forming helium. This process, known as nuclear fusion, releases a tremendous amount of energy, causing the protostar to shine brightly. Thus, a star is officially born. Throughout its life, a star continues to burn its hydrogen fuel, maintaining a delicate balance between the inward pull of gravity and the outward push of energy from nuclear fusion. This stage, known as the main sequence, is where a star spends the majority of its life. But stars, like all things, age. As they exhaust their hydrogen fuel, heavier elements like helium begin to fuse, creating even heavier elements. The star expands, becoming a red giant or a red supergiant depending on its initial mass. However, the fusion of heavier elements doesn't generate enough energy to counteract the force of gravity. Eventually, the star's core collapses under its own weight, triggering an explosion of epic proportions. The outer layers of the star are blown off in a brilliant display of light and energy, outshining entire galaxies for a brief moment. This dramatic end to a star's life is what we call a supernova, so when a star exhausts its fuel, it goes out with a bang, not a whimper. This bang, dear viewers, is a supernova. Imagine a blast so powerful it outshines entire galaxies. Welcome to the world of supernovas. A supernova, in its simplest terms, is a stellar explosion. It marks the end of a star's life cycle, and it's a spectacle of cosmic proportions. But how does it happen? Well, when a star exhausts its nuclear fuel, it can no longer maintain its own weight. The core collapses under gravity's relentless pull, triggering a cataclysmic explosion. This is a supernova. These celestial fireworks are not just a feast for the eyes. They're astoundingly powerful. The brightness of a single supernova can rival that of an entire galaxy. Yes, you heard that right. One dying star can illuminate the sky with as much light as billions of stars combined. But it's not just light that a supernova emits. It's a cosmic powerhouse, releasing an unimaginable amount of energy. In fact, for a brief moment, a supernova can outshine the entire output of the Milky Way. It's a display of nature's raw power on a cosmic scale. Now, you might think that after such a grand spectacle, the show is over. But that's far from the truth. The remnants left behind by a supernova are equally fascinating. Let's take a quick detour to explore these cosmic leftovers. First up, we have neutron stars, the densest objects in the universe. They're so dense that a teaspoon of neutron star material would weigh as much as a mountain. Can you wrap your head around that? Then we have black holes, objects so dense and with such strong gravitational pull that not even light can escape them. They're the ultimate cosmic mystery, a puzzle that scientists are still trying to piece together. So when a star dies, it doesn't just fade away. It goes out with a bang, lighting up the cosmos, and leaves behind some of the most intriguing objects in the universe. It's a life cycle that's as poetic as it is scientific. In the grand theater of the universe, supernovas are the most dazzling performances. Stars and supernovas don't exist in isolation. They live in cosmic cities known as galaxies. Just as humans build cities, stars cluster together in these massive cosmic metropolises. There's an unimaginable diversity in these celestial cities, each one home to billions upon billions of stars. In fact, it's estimated that there are more stars in the universe than grains of sand on all of Earth's beaches. And just as every grain of sand is unique, so too is every star, each one contributing to the vibrancy of its galaxy. Galaxies themselves come in a variety of shapes and sizes. There are spiral galaxies like our very own Milky Way, with its arms gracefully curving around a bright central bulge. The stars in these arms are a mix of old and young, giving spiral galaxies their distinctive blue and red hues. Then there are the elliptical galaxies, the most common type in the universe. These are the cosmic equivalent of bustling metropolises densely packed with older red stars. And let's not forget the irregular galaxies, the cosmic wildcards. These galaxies, shaped by gravitational interactions and collisions, lack a definitive structure but are brimming with star-forming regions. They are the cosmic equivalent of frontier towns, untamed and full of potential. Each of these galaxies, whether they're spirals, ellipticals, or irregulars, is a vibrant city of stars, each one humming with the energy of billions of stellar inhabitants. Our own Milky Way is a cosmic city in its own right, a bustling metropolis of stars, gas, and dust. It's a spiral galaxy with a central bulge surrounded by 4 major arms that wind outwards. Each arm is a unique neighborhood with its own collection of stars, planets, and other celestial bodies. Within these galaxies, the cycle of star birth, death, and rebirth continues, painting a dynamic picture of the cosmos. Our universe is a grand tapestry, woven from countless threads of light, each one a star within its own cosmic city. The story of the universe is written in the stars, and it's a story that's still being written. From star birth to supernovas, from lone stars to vast galaxies, the universe is indeed a cosmic dance, a dance that's been choreographed over billions of years. We've journeyed through the life and death of stars, observing the spectacular explosions known as supernovas. These celestial fireworks not only dazzle in the night sky but also play a crucial role in the creation of life-giving elements. We've explored galaxies, those cosmic cities teeming with billions of stars. They are the grand stages of this cosmic ballet where stars are born, live, and die in a continuous cycle of creation and destruction. And so, the universe performs its silent symphony, an orchestra of celestial bodies moving in harmony. It's a dance of energy, matter, time, and space. A dance that's both chaotic and ordered, violent and serene. In the end, the universe continues its silent symphony, with supernovas as its grand crescendos and galaxies as its sprawling stages.